Hey guys, this is Mr. Sal. Thanks for watching. This is just a quick lesson on addition and subtraction of polynomials. So please like and subscribe and comment in the section below. Thank you. Really, with adding and subtracting polynomials, we're just looking at combining like terms. That's it. Okay. Sometimes though, again with the subtraction, we're going to be taking stuff away instead of putting it together, right? These are just some terminology we may use a little bit. It's not really necessary that you know it. It's not going to be part of the exams, but it may help you to understand what we're talking about. Like a monomial can be one term, like x. It could just be a number, like 5. But it doesn't matter what the exponent is either. It could be like something like x cubed as well. Okay. That is still a monomial, one term is all we're looking at there, okay? Binomial is 2 terms, something like x plus 2. I mean, again, we could look at exponents as well, which we will eventually. Trinomials usually have 3 terms. Doesn't matter what the exponents are right now. 5x to the 8th plus 2x to the 6th minus x. 3 terms constitutes a trinomial, and then a polynomial just has 4 or more, technically speaking. Okay. In general, we could just refer to any of these as polynomials and would be good to go, though. So, minor technicalities on these. These are more. These terms are ones that you should be more familiar with as vocabulary. The degree of the term is the sum of the exponents of the variables in the term. Just sometimes you'll have more than one variable. Okay. It's not too common yet, but we may see it. The degree of the polynomial is the largest degree of any term in the polynomial, so we just look for the highest power, really, is what we're looking for there. And then the coefficient is usually number in front of some variable. It's being multiplied by the variable. The leading term is the term with the highest degree, and then the leading coefficient is the leading term's coefficient. Sometimes they're separated by addition or subtraction, but whatever they're separated by, it takes that operation as its positive or negative. So if it was subtraction, it would be considered a negative term, okay, which we'll see. So it's just asking, this is not in descending order, which eventually will need to be, but that's okay right now. So like this first term, right? The first term, we're looking at this 2x cubed. The degree, now this only has one variable, x, and its power is 3, so it's a degree of 3, that term. And the number it's being multiplied by, the x cubed, is 2. The second term, I'm looking at this negative 2x squared, so the degree now is 2 from the exponent, and the coefficient is the negative 2 in front of the x squared. This third term is negative 8. That's going to be your coefficient. It really would be kind of like negative 8 times x to the power of 0. So it has, since it doesn't have an x, we say it has a degree of 0. And then our fourth term, negative 3x to the 4th. Again, the exponent is 4, so that's our degree. And then it's being multiplied by negative 3, the x to the 4th. Then our fifth term, 6x, that's positive 6x, so it's a degree of 1. It didn't show the exponent for the x, but it is 1. And the coefficient is that positive 6. Well, then the leading coefficient, well, we need to find the leading term first, I suppose. And that's going to be the term with the highest degree. So I'm going to look at the powers of the x's, and the highest power is this power of 4 right here, right? So the degree of the leading term, well, I guess the leading term itself is the negative 3x to the 4th. So it's the leading coefficient is negative 3. What's the degree of the leading term? 4. And since that's our leading term, the degree of the polynomial is 4. Because it's our leading term. Okay. So with the degree of the polynomial, we only really need to focus on the leading term, which in this case is negative 3x to the 4th. So adding and subtracting polynomials is the same as just simplifying them. Some of you guys would rather look at subtraction as distribution of a negative 1. Like we just usually call this combining like terms in general. And I may refer to it more as that anyways. We just need to keep in mind that whatever operation is separating terms, it's going to keep the operation to its left, right, as a positive or negative. Yeah, and when we subtract polynomials, we got to be careful, because if we saw something like this, 5 minus x minus 3, like this, again, we could look at that as distributing a negative 1 into the parentheses, or we could take the opposites of what's on the inside of the parentheses. So the opposite of x is negative x, and the opposite of negative 3 is positive 3. It really depends on how you prefer to look at it, okay? Adding, again, is literally just looking for like terms. But we could look at it a little differently, all right? So in this case, we got negative 7x to the 7th minus 3x to the 4th. And if I stack these, I just need to make sure that like terms are in the same columns, kind of like a matrix, right? So in other words, instead of writing the second binomial as 10x to the 4th plus 18x to the 7th, I'm going to write this as 18 or positive 18x to the 7th, and then positive 10x to the 4th, okay? So again, this lines up the terms with the same degrees in columns like this. Now what I can do is, since I'm adding these together, I'm going to add negative 7x to the 7th to 18x to the 7th, which would leave me with 11x to the 7th. And then I'm going to take negative 3x to the 4th and plus 10x to the 4th, which would leave me with positive 7x to the 4th. And that's it. That's as far as we have to go on that. Let's say we like the old-fashioned way, all right? So this is all addition, so there's no need really for the parentheses at all. So when we see it like this, it may be, well, I guess we're kind of used to identifying like terms and then combining them like this, right? So negative 7x to the 7th plus 18x to the 7th would give us 11x to the 7th. And then negative 3x to the 4th combined with 10x to the 4th would give us a positive 7x to the 4th. Again, the method is not necessarily important as long as you choose one or the other, okay? Because either method if I saw on an exam would be fine. So on this one we got to be careful, especially if we do stack them. So the first polynomial, in this case binomial, it's never going to change unless there's something in front of it to multiply it by. And since it's not showing anything, we're just going to keep it the same. Now in the second binomial, I can see I've got an a to the 5th here, which is a negative 22 a to the 5th. But this negative 5a to the 9th doesn't have any other like terms from the first binomial. So I'm going to set it off to the side, negative 5a to the 9th, right here, okay? So now when I combine these, I'm going to add them together, right? So I got 15a to the 5th plus negative 22a to the 5th. Leaves me with negative 7a to the 5th. Now this negative 8a to the 7th has nothing to combine with, so it just remains negative 8a to the 7th. And also the negative 5a to the 9th has nothing to combine with, so it stays as well. Technically though, and I want to say on the homework it wants these in descending order. So we start with the highest degree term, which is -5, a to the ninth. That's our leading term, right? And then we go to the next highest degree, which would be -8, a to the seventh. And again, for those degrees, I'm just looking at the powers, right? And I've got -7, a to the fifth. So I went from the highest power, next highest power, and then the lowest power. And then that's how I have this written. That would be considered formal descending order. So again, be careful on these, because if the degrees or the powers don't match, then we can't combine these, right? Now once again, this one's just a straight polynomial because it has 4 terms. But it's just going to stay the same because, again, it's not being multiplied by anything. Now both of these polynomials are written in descending order, and I did leave a space. Well, I guess I shouldn't have. Either way, I left a little space here in the front because we got this -2x to the fourth, which doesn't have anything to stack with in that first polynomial. So I'm going to set that off in front, -2x to the fourth. It does have an x cubed to combine with, and that's a 1x cubed. And then we got an x squared, -9x squared. There's no x's there, so I'm just going to skip that and go right into the -11. Okay. So I've separated these with spaces on purpose, and now we're just going to add these together, each terms that we have, like terms. Now again, there's no -2x to the fourth to combine with, so it just remains. And then we've got -4x cubed plus the 1x cubed would leave us with a -3x cubed. And then in x squareds, we got -12 minus 9, which is -21. Then we got the -x, which again has nothing to combine with. Then we got 12 minus 11, which would leave us with +1. And this is in formal descending order anyway, so that turned out pretty nice. But we have to be careful again, because sometimes we just want to start stacking stuff, and we end up with -4x cubed stacked with the -2x to the fourth. But since there's not like terms, we shouldn't stack those together. Okay. Both of these are in the same form, these two trinomials or polynomials. So we can just stack these directly, which is nice. Okay. So I got that first, and we're going to add that to the second polynomial.
Are we adding or subtracting?
It does. Would you guys like to subtract them? It's not going to matter. We haven't done any subtraction yet, right? So should we try subtraction? We can do that, right? We'll just get rid of that and make it minus. All right, so let's subtract these then, all right? So we're subtracting each term, and we have to keep in mind if we're subtracting a negative in these cases, right? -3x squared minus 3x squared, that's going to cancel out. That gives us 0x squareds. Then I've got -7x minus 6x, which would leave me with -13x's. And then I've got 8 minus -7, which is the same as 8 plus 7. So that would end up being a +15. Now the homework, and even I don't really want you guys to write that 0x squared stuff. Just get rid of it. Okay, it's eliminated, which we've seen before, so it's nothing new for us. Since it is subtraction, we are subtracting each of the terms from each other. So I mean, in this case, we'd have to be careful, because if there was a 0 or any skipped terms, then we'd have to keep track of that 0 minus whatever the heck it is.
Why is
Subtraction again, we've got to look for the like terms and just stack them, and then we'll look at the operation in between. All right, so I got that first one, and then I'm just going to write that second trinomial just the way that it is, but stacked, right? But we're subtracting these polynomials, so I'm going to subtract each of the terms. 7x squared minus 8x squared, 2x minus -4x, and -1 minus -6. So now when we find the solution to this thing, for my x squareds, I got I got 7 minus 8, which is -1. And then for my x's, I've got 2 minus negative 4, which would be positive 6 x's. And then for my singles here, negative 1 minus negative 6 is going to be positive 5. Now again, we don't usually write that 1 there in front, that leading coefficient. I would be okay if you did on a test, but I believe the homework does not want to see that there. I could be wrong though. Alright, again, we're just looking at stacking these values, but again, since this is subtraction, we have to be aware of the zeros, or the empty spaces where nothing is stacked with other stuff. Alright, so that's the first polynomial, and then again, I'm just going to write the second one, but I'm going to stack the values that we have with the like terms. So I got 8x to the 5th, negative 9x to the 4th. There's no x cubed there, so we're just going to skip that and go right into the x squareds, which has nothing to stack with, and then there's positive 3x, and then no singles to combine there. Now again, this is subtraction, and we got to keep track of that 0x to the 4th, because we need to subtract the negative 9x to the 4th from it. If we subtract 0, it's not usually a big deal though. So even if we show that as 0x cubed, but we do want to keep track of the 0x squared, which we'll subtract. 12x minus 3x, and then 1 minus 0 if you want. So in x fifths, I've got 11 minus 8, which is 3. Now again, we're looking at this 0x to the 4th minus negative 9x to the 4th, which makes that a positive 9x to the 4th. 8x cubed minus 0x cubed would leave us with 8x cubes. And then once again, we got 0 minus negative 7 in x squareds, which makes that a positive 7x squared. 12x minus 3x, that's not too bad. That's a positive 9x. And then 1 minus 0 is positive 1. Yeah, that ends up being a pretty long polynomial. But again, the key here is paying attention to these blank spaces, particularly in the first polynomial. Because with subtraction, that's going to be subtract, well, in this case, subtract negatives right there. There's a lot of words in this word problem, just kind of throws off. In a Northern European country, the formula models the number of deaths per year per 1,000 people, Y, for people who are X years old. And this is only for the ages between 40 and 60. Approximately how many people per 1,000 who are 41 years old die each year? For the purpose of this problem, we'll round this to the nearest whole number. That's great. So, we're looking at 41 years old, and X represents years old in this case. So in this formula, we're replacing the X's with 41 years. Well, that's not too bad. We could pretty much just plug this directly into the calculator and see what we get. Alright, so this is the value I got out of my calculator from punching this in. And you do need to be careful. Most of your calculators should have that parentheses option on there, which you should use. Alright. This one did say to round to the nearest whole number. So we're just going to say that y is 7. So I think technically 7 people per 1,000. 7 deaths per year per 1,000 people. That'd be good. It's a word problem, so we should label the answer there.